So in this video we're going to convert cylindrical equations into rectangular form or rectangular equations. So here I'm given an equation r squared times the sine of 2 theta plus z squared is equal to 0. I know it's an equation in cylindrical form because the only variables showing are r, theta, and z, corresponding to our cylindrical coordinate system. And to get it into rectangular coordinate system, I need to rewrite it so that it only contains x, y, and z. So I need to eliminate the r and the theta from the equation. And what I want to notice is that the sine of 2 theta is a trig identity. So the sine of 2 theta equals 2 times the sine of theta times the cosine of theta. So I'm going to rewrite the sine of 2 theta like this, trying to get it closer to these forms that I see right here. So I'm going to do r squared times 2 sine theta cosine theta plus z squared is equal to 0. And then r squared is really just an r times r, and these are all being multiplied, and the order of multiplication doesn't matter. So I'm going to rearrange it in a way that allows me to use what I see up here. So I'm going to rewrite this as 2 times r sine theta, keeping this r with the sine theta, and then this r will move him because multiplication is not only commutative, but it's also associative. So I'm able to move these multiplications around any way that I want. So 2r sine theta times r cosine theta, moving one of the r's in with the cosine theta. And then once I do that, r sine theta is just y, and r cosine theta is just x. So I want to recognize that I have 2 times y times x, or because order of multiplication doesn't matter, a 2xy. This guy here is an x, this guy here is a y, but I can switch the order of that multiplication if I want to. And then I could leave it like this. This would be okay. Or I could solve it for z squared. So z squared equals negative 2x times y. So one more example. So here on this slide we have r equals 2 cosine theta. R equals 2 times the cosine of theta. It's in cylindrical form because it has an r and a theta. The z variable's missing, which is okay. That might indicate that we have a cylinder, something extruding parallel to the z-axis, for example. The idea is if I can get an r cosine theta, that will allow me to replace it with an x. So what I'm going to do is multiply both sides of the equation by r, so that I get a 2r cosine theta on the right hand side, and that will allow me to make a replacement of this term with x. And here I have an r squared term on the left hand side, but r squared is just x squared plus y squared. So I'm going to make a replacement. X squared plus y squared equals 2 times x. And then we could look at attempting to simplify this to see if we can figure out what it is if we want to. So I've got 2x. Here I have x squared plus y squared. So we could subtract the 2x from both sides. X squared minus 2x plus y squared equals 0. And then if I complete the square on this, I take half of negative 1. Half of negative 2 is negative 1, and negative 1 squared is 1. And if I add 1 to that side, I need to add 1 to this side. So bringing stuff up here, x squared minus 2x plus 1 factors as x minus 1 quantity squared, plus y squared equals 1. And it looks like we have a circle in the xy plane that's centered at negative 1, 0, and that circle would be extruding because the z variable is missing. It would be extruding perpendicular to the xy plane and parallel to the z-axis. So indeed this is a right circular cylinder that is centered at 1, 0.